Hello and welcome to today's webinar, where we'll give you the latest updates on the most recent nRF Connect SDK release version 2.7.0. I will be your host for today's webinar. My name is Tiago Montt, and I'm a developer marketing manager here at Nordic Semiconductor. So, exciting developer is actually one of Nordic's pillars and one of our strategic priorities. And so we focus a lot on great developer experience with our software and tools and our outstanding technical support. Some of the ways how we interact with developers are through these tech webinars, where we cover a variety of topics. It can go from high-level technology intros to more hands-on type of coding content. Then we have DevZone, where you can find the developer-oriented DevZone blog, but primarily this is our tech support. This is where our tech support team hangs out and where you can post your questions and get tech support from Nordic. Then we have Tech Talks. This is our recently launched unified documentation portal where you can find all of Nordic's technical documentation. That means across hardware, software, development tools, and also nRF Cloud. And last but not least, we have the Dev Academy. This is our online interactive learning platform. This is where you can find courses with hands-on exercises to help you really sort of accelerate your learning curve on a variety of topics. So as of now, we have 5 courses available. So we have 2 courses on the nRF Connect SDK, the fundamentals and the intermediate course. And then we have, we have fundamentals courses on Bluetooth LE, Wi-Fi, and cellular IoT. All right, so for today, we're going to start with the generic updates on the SDK. Then we're going to have updates on development tools, including a demo, updates on Matter, updates on Wi-Fi, also with a demo. We'll have DECT NR Plus updates, and the last topic will be Edge AI updates, also with a demo. And of course, at the end, as already mentioned, we'll have the Q&A. So during today's webinar, you will hear the term supported and experimental very often. So these are our 2 software maturity levels. So I believe the terms are, self-explanatory, but in a nutshell, experimental indicates that it's not suitable for production. It has incomplete feature implementation, verification. The API definition might change, and we also don't guarantee bug fixes nor improvements. Experimental features may also be removed without notice, but normally the course of action is that these features will become supported at a later stage. You're, of course, free to use experimental features for prototype and evaluation, but just keep these things in mind when doing so. And then, of course, supported means essentially that the feature is ready to be used in a production environment. So we have complete implementation and validation, stable API, and a commitment to fix critical bugs and security issues. And also removing supported features will follow a deprecation process where they first get marked as deprecated, and then we keep the feature for at least 2 releases before removing it from the SDK. And usually the feature gets deprecated when there's a newer or better feature that gets introduced, and it will replace the deprecated feature. So the deprecation period is really meant to give customers time to adopt this new alternative. Okay, so with that being cleared out, let's then get started and let's look at the generic updates in nRF Connect SDK 2.7.0. So first, looking at the experimental features, the first update is in our nRF Cloud libraries, which give you easy access to our various cloud services directly from our cellular IoT devices. So the nRF Cloud CoAP library, which stands for Constrained Application Protocol, is now using the SO keep open socket option as experimental. So CoAP runs on top of UDP, and this option keeps the UDP socket open during temporary network outages, avoiding unnecessary handshakes to reopen the socket, and with the immediate benefit here being you save data and power, meaning that you can both reduce the data costs with the removable operator and also extend the battery life out in the field. One thing is that the SO keep open option is only available on modem firmware 2.0.1 and above. meaning that this is supported on nRF 9161, nRF 9151, and nRF 9131, but it's not supported on nRF 9160 because that one runs modem firmware version 1.3. The latest is 1.3.6. So just a reminder here that we'll continue to maintain the modem firmware for nRF 9160 with bug fixes, but there will be no new features. So if you're starting a new cellular IoT design, we highly recommend that you look at our most recent devices in the nRF 91 series. Then on Bluetooth LE, we introduced path loss monitoring in the soft device controller, and this is part of the LE power control feature. So path loss monitoring is defined in the Bluetooth core spec and in the context of LE power control as the difference between the remote transmit power and the average local RSSI measurement for that connection. So this feature then allows the host to define 2 or 3 path loss zones known as low, middle, or optionally then the high path loss zone. And then the controller can then inform the host if there are changes in the zone which the path loss falls within. So using the HCI events, which is actually the only interface that we have for this feature at the moment, as we don't have a host stack API for it. So for example, if you have 2 connected devices and they move further away from each other, the path loss zone would drop from middle to high. So that would trigger the controller to notify the host of this change, or vice versa. If they get closer together, it would go from high to middle or middle to low, depending where it started from, and this would also trigger a notification to the host. Okay, then moving to supported features, and we'll have a little bit more in-depth information on the next few slides. So the first highlight here is the introduction of Google Find My Device, or FMD for short. This is a really cool feature. This allows you to create a locator device that is compatible with the Android Find My Device app. I'll leave a link here on the slide. It doesn't have to be, specifically a locator device as such, or like a dedicated tracker. You can also see this as a location feature that can be added to other devices so they can be easily tracked. Think, for example, an e-bike or headphones or any other device that has Bluetooth LE capabilities. So FMD is something that can be, is basically a feature in your firmware, essentially. So we also introduced this sample to showcase FMD, this Bluetooth fast pair locator tag sample. So you can use that as a starting point to see how it works and then integrate that into your application. Then we have 2, let's say, non-firmware related features in the SDK. These are extremely important as they are quite significant, and they also introduce, potentially breaking changes to the SDK. And we'll also look into these a bit more in depth in just a few minutes. So the first one is SysBuild. This is an improved and extensible system for multi-image build, and hardware model V2, which is also an improved and extensible system for defining ports. Okay, so starting with the Find My Device, let's have a better look here to understand, let's say, from a high level, how this enables location tracking. So Find My Device is leveraging a network of hundreds of millions of Android phones worldwide as a sort of, crowdsourced location infrastructure, let's say. So these Android phones are scanning for Bluetooth LE beacons, and essentially FMD defines a specific data format for those beacons. So they indicate that there's an FMD asset in the vicinity. So it will be a Nordic SoC-based product that's, sort of broadcasting these beacons. So this information then gets reported, by whichever device or devices that pick up these beacons. It gets reported to the Google Cloud server, and then the owner can, be made aware of the approximate location of these assets. So FMD includes the unknown tracker alert service. So this helps protect user safety by, alerting them if there's an unfamiliar FMD enabled device, typically a simple tracker that's detected moving with them. And there are trackers in the market today based on Nordic hardware and software that's leveraging this FMD feature, most notably from Jipolo and Pebblebee. So this is something that was made public when we announced support back in April, and I have a link here to the announcement. But as said, FMD can be built into virtually any application with Bluetooth LE capabilities, where it makes sense or where it adds value to the product. So if you want to dive a little bit deeper into the technical details, you can get the specifications directly from Google. I'll leave a link on this slide, but you can find this very easily by just typing Find My Device specification, and you'll find it first thing on the Google search. And last thing to note here about FMD is that if you want to create a device with FMD functionality, you need to get it registered. and approved with Google. So that's something that needs to be put in place first before you can go to market with your device. You'll need the keys and some data from Google and some guidelines on how to market your product. And then you can find a link to this registration form in this FMD specification page. So you can check that out if this is something that you're interested in. Okay, then moving into SysBuild. So SysBuild is a higher level build system based on CMake that it can be used to combine one or more nRF Connect SDK build systems and optionally additional build systems into a sort of hierarchical build system that enables multi-image build. So often building applications in nRF Connect SDK involves multiple images. For example, you have MCU bootloader, then have an image for the network core. If you're on the nRF 5340, you'll have the TFM for the trust zone. So we want this development process to be as simple and smooth as possible. We don't want you to build different images separately and then worry about integrating them and flashing them by yourself. So SysBuild allows you to build your primary application, for example, together with the MCU bootloader, then flash them into your device and debug the results. So, or in the case of Bluetooth LE application running on the nRF 5340, you'd include the network core image seamlessly into the build system and flash that into the device. So the way it works is by configuring and building at least a single application, then optionally as many additional projects as you want. So it provides a clear separation, files and boundaries, and it's compatible with upstream Zephyr as well as with the new hardware model V2. So we're now introducing SysBuild as supported in nRF Connect SDK 2.7.0, and all the in-tree samples and applications are using SysBuild. However, for out-of-tree applications, so for your own applications that you're customizing out-of-tree, it's not used by default. So this requires an active transition, and we'll show you how that can be done with the commands. So this is replacing the multi-image builds parent-child images, which is now deprecated. So SysBuild is the replacement for that. It will be removed on one of the upcoming nRF Connect SDK releases. So for now, we're keeping that. As mentioned, when we introduce new features and we deprecate them, they will be there for a few releases. But of course, we highly recommend transitioning to SysBuild as soon as possible, and you'll find a migration guide in our documentation. I'll also leave a link on this slide. So this diagram is here trying to, let's say, depict the challenge of having multiple images without the multi-image build system. So if you have your main application and you have a bootloader, then you have to deal with two different projects, and you have to manually sort of plan and maintain the offsets and partitions so that these images align correctly in Flash, and then you build and flash each image sort of separately, so there's room for user error in this kind of setup. Well, SysBuild is basically automating and making this process straightforward. So the current multi-image parent-child image system, which was a Nordic specific implementation, also had challenges, and there were slightly different file structures. And then, for example, the kconfig option to add a bootloader, so that was the config_bootloader_MCU boot, was inside the application configuration project file, so the prj.conf file, which didn't make a lot of sense. So now with SysBuild, there's a unified structure for managing configurations, both globally. So you have configurations that can apply to all the projects within SysBuild. So those will be managed by SysBuild and have this SB prefix. And then you have a clear separation of ownership and clear kconfig tree for each individual image, which have their own kconfig configurations, and then the global configurations with SysBuild. So you get just one image that you flash to your device without having to worry about some of the things you had to worry about in the past. So here's an example of the serial LTE modem application in the SDK using the multi-image versus SysBuild. So in both cases, when building the application for the Thingy91, the MCU boot image will be built and flashed onto the device. So we can see the changes in the folder from child image to SysBuild. So this is where the MCU image can be configured. So you have these kconfig fragments, and you enable MCU boot in that configuration directly into SysBuild. So, and as mentioned, that if you have out-of-tree applications, they're not using SysBuild by default. You need to need to transition actively. So this is how you can do it. You can either add the SysBuild option when invoking westbuild command, or well, on the other hand, if SysBuild is default and you don't want to use SysBuild, there's also the no SysBuild option. But the other way to change it is by changing the West configuration to use sysbuild by default. So there's something you can do once, and then you don't need to add the sysbuild option every time you try to build an application. So sysbuild was one of two major updates. The other one is hardware model v2. So one of the main problems with the old legacy hardware model is that it didn't really handle boards with multiple targets very well. So it was mainly intended for hardware with a single target. So meaning the hardware had one SoC with one CPU running the application. And when the hardware had different targets, whether it's a multi-core SoC or multiple SoCs or even multiple architectures, the board definition need to be implemented in a complicated way with many files spreading out across different folders. So it basically doesn't really fit the demands of modern and more capable hardware. Therefore, hardware model v2 was born as an improved and extensible system for defining boards, both in nRF Connect SDK as well as an upstream Zephyr. So with the hardware model v2 boards, they're no longer located under architecture. The reasoning here is that a single board could have multiple architectures, and instead now the board files are located under their vendor. It also offers reusability in sysbuilds, which means that you can select to generate extra images for things like MCU boot or network core in a more coupled way. There's a new common description format for everything from the board's SoCs, series, families, family architecture, CPU cluster, variants, revisions, and this new common description is YAML based as well. We'll show on the next slide. And this common description YAML file sort of lay the foundation for this flexible and extensible system for defining boards. In 2.70 SDK and onward, this is now the default board system, so it's kind of the same approach as with sysbuild. It should not affect out of tree boards that use the legacy model. However, support for custom out of tree boards using the legacy model will be removed in an upcoming SDK release, similar to the multi-image build feature. So we recommend transitioning to the hardware model v2 as quickly as possible. And to help with that, we have a migration guide. And there's also a very handy conversion script available. So you can find that in our documentation. You have a link, a link on this slide. So here's an example of a board definition with the legacy and the new hardware model using the nRF 9160 as an example, because that has multiple SoCs. So you have the nRF 9160 SIP for cellular IoT, and you have the nRF 52840 SoC for Bluetooth LE. So with the legacy model, the board implementation was sort of scattered across different folders, one for each device essentially. And the new model puts everything into the same folder. Then you have this YAML file that defines your board with its various devices and also some other metadata, like for example the revision. So as mentioned earlier, this is now the default board system in nRF Connect SDK 2.70 and onward. So all boards have been migrated to use hardware model v2. If you have a custom board, it needs to be updated with a new model during this transition period. And we offer the migration guide and the conversion script. And here you can see some more pragmatic changes, let's say, when invoking West build, where essentially the underscores in the target name are replaced by /. And then when building a specific revision, that gets sort of swapped out with the SoC. So you have SoC, you had SoC revision, now we have revision and SoC. Okay, so that was it for generic updates. We can move on to development tool updates. So nRF Connect for VS Code. So to these, due to these significant changes that we just went through on sysbuild and hardware model v2, developing with nRF Connect SDK 2.70 is experimental using nRF Connect for VS Code. In the release version, actually, there's no support for nRF Connect SDK 2.7.0. You must switch to the pre-release version in the extension. And this can be done very easily if you go to the top on the extension itself. That allows you to switch between release and pre-release version. So if you're in the release version, you will see this saying switch to pre-release version. If you're on the pre-release version, you'll see the text will read switch to release version. So you can easily switch between these two. And doing this switch doesn't have any impact on your existing projects for previous SDK versions. So we're hoping to get support for nRF Connect SDK 2.7.0 in the release version in the coming weeks. So stay tuned for updates on that front. Then we also introduced a new mobile app, nRF NFC Toolbox, which is quite an essential tool for developers working with NFC-enabled devices. So this is essentially a sort of NFC Swiss Army knife, let's say, allowing you to read and write data. So in NFC, this is data exchange format, so NF messages, copy data between NFC tags, and also do connection handover to Bluetooth LE. So this is meaning this out of band pairing, where the security data is exchanged through NFC, so that the devices can pair and communicate over an authenticated and encrypted link. This is a Android-only mobile app. And to test this out, you need a kit with NFC support, like for example, nRF 7002 DK. Essentially, all the Bluetooth kits also have NFC support. And I'll showcase a quick demo of this app using the nRF 52 DK. So let's move on to the demo now. So for this demo, I'll use the NFC writable NF message sample from the SDK. You can find the documentation if you go to nRF Connect SDK documentation in Tech Talks. Go down to samples, expand that, and then you'll find NFC samples, expand that, and you'll find this one right at the bottom. I've already built and flashed this into the nRF 52 DK, which I have connected to my computer, and then of course I have the NFC patch antenna connected to the kit, and then I have the serial terminal application from nRF Connect for desktop, which we'll use to see the messages coming out of the kit, and then I have an Android device that has the mobile app installed. So first I'll go and just press reset on the kit, so we'll make sure that the firmware is running, has booted correctly, and we can see that there's an NDEF file record available. So we'll go to the mobile app, open that, and we'll just tap to read the content of the tag. Okay, there we go. You can see that tag info here at the top, some metadata here. Then we'll go end of message, tells us that there's one record. And if we go and see this record, it's a URI type record. And it has the URI for nordicsemi.com. So it offers us a shortcut to open this URI right there. Okay, let's go back to the mobile app. We can also write using the mobile app. So if we go to the hamburger menu here on the top left, we have this write capability, and then we'll just need to add a record. So we could clone a tag. So if we just get the mobile handset close to a tag, we'll clone all the data. We can use existing records if you have them saved on your phone, or we can just create a new record. So that's what we're going to do. We'll create a new record. Let's create a URI record, which will overwrite the one that is on the firmware, which is currently on the firmware. So we'll choose the prefix. So let's just use the Dev Academy URL. So nordicsemi.com. And we do confirm. And then to write this, we'll have to click publish, and we'll just get the phone close to the tag. Okay, there we go. We see that there's a green check mark, tag discovered, tag written successfully. We also see here the messages coming out of the firmware that the NDEF message was successfully flashed. What we can do now is to read that back and make sure that indeed we have updated the data. Okay, so we have the same information at the top as expected. And then if we go to this URI record, we see that's been updated with academy.nordicsemi.com. And we could go and open that website and see my colleague Ali right there at the top on his introduction video. We can add other types of data. So I'll just add one more for demonstration purposes. But of course, this is a very handy mobile app that allows you to do essentially everything that's possible over NFC. So we'll just go back to write. Let's add a new record, maybe something even simpler, like plain text. So of course, hello world, collapsing here the keyboard, confirm. Again, we need to click publish. We'll get mobile app on top. Okay, tag discover written successfully. Again, we see the message here coming out of the kit confirming that it was successfully flashed. And now we go back to read mode and just get the tag there on top. And now we can see that we should have, yeah, of course, we have now 2 records. So the SIM record we had before with the academy.nordicsemi.com URI, and now we have this text record with the text hello world. Okay, so that was the nRF NFC Toolbox mobile app demo, and let's continue now with the rest of the topics in the webinar today. And now for updates on Matter. So we have a significant update in this SDK release with support for Matter 1.3. So this applies to both Matter over Thread, which is supported on the nRF 52840 and nRF 5340, as well as Matter over Wi-Fi. So this is supported on the nRF 5340 plus the nRF 7002 Wi-Fi companion IC. So that hardware combination also offers the option of switched Matter over Wi-Fi and Matter over Thread. So you could essentially create a device that runs as Matter over Wi-Fi out of the box. And then if the customer has a Thread border router, they could switch to Matter over Thread operation, which would extend battery life. So if you're interested in this solution, I recommend checking out the nRF Connect SDK 2.3.0 webinar, where we also had a demo of this door lock sample that switches between Matter over Wi-Fi and Matter over Thread. So some of the highlights of Matter 1.3 include energy reporting and management. So this will help users understand and manage their energy use as a way of reducing their carbon footprint. And these new energy-oriented features also include EV charging. So enabling the EV charge to be controlled through the Matter network, for example, manually start or stop charging, adjusting charging rates, and many other options like charging only when the prices are at a certain level, for example. Water management was also introduced with support for leak and freeze detectors and rain sensors, water valves, and other features. Then also new major appliance types were added, for example, ovens, microwave ovens, cooktops, extractor hoods, laundry dryers. And well, last but not least, also there were a few user experience enhancements. So one of those is scene. So essentially providing a standard method for device makers to set, read, and activate scenes. So this allows one command to sort of change settings across multiple devices. For example, imagine you have a movie scene where your lights dim to 10%, your curtains close. So there's also this new scene support will allow for these things. Then there's also command batching. That's more of a sort of a technical feature, but technically speaking, what this does is that it allows multiple commands to batch into a single message, and the goal here is to minimize the delays between the execution of those commands because they're all received at the same time. But for the user, essentially the biggest benefit is that they will see a more synchronized experience. So especially minimizing the popcorn effect that it's sometimes seen in smart lighting applications where you have these different devices reacting to commands in different times. So you'll see sort of the lights being controlled or actuated at different times. The CSA, though, the Connectivity Standards Alliance, which is behind the Matter standard, wrote an extensive blog post that goes into more details. So if you're interested in Matter 1.3, I recommend reading that if you want to learn more. All right, moving on to Wi-Fi. First thing is that we have added random MAC address generation at boot time as experimental, and this was added in the nRF Wi-Fi driver. So MAC randomization essentially helps ensure the privacy. It conceals the original MAC address. It makes it significantly harder to track a device based on its MAC address, especially when it's connected to public access points. There are also some new supported features. So the first one is Wi-Fi and Thread coexistence, which is a mechanism to share the 2.4 gigahertz spectrum between Wi-Fi and another protocol. This was already available in the SDK for Bluetooth LE. So you had Wi-Fi and Bluetooth LE coexistence, and now that same mechanism is supported for Thread. Then we have software-enabled access points, commonly referred to as SoftAP, but for provisioning use case. So this offers a sort of a more resource-optimized solution to provision Wi-Fi devices than the previous solution we had. There was provisioning over Bluetooth LE. But in that case, you need to include the Bluetooth stack just for the provisioning phase, assuming that you don't really need it for regular operation. So that, increases your flash and RAM demands on your application. So now you can use Wi-Fi. You'll use it obviously as a station device, which is the most common use case in IoT, but you can also enable SoftAP for the provisioning piece. Also supported is raw Wi-Fi reception in both monitor and promiscuous modes, and some new samples. So the Wi-Fi SoftAP based provisioning, Wi-Fi promiscuous, and Wi-Fi thread coexistence that showcase some of the features that were added as well. Actually, some of these features were already in the SDK as experimental. They're just now the maturity went up to support it, so they can be used in a production. And we're going to show now a quick demo using the SoftAP based provisioning sample together with our nRF Wi-Fi provisioner mobile app to show how this works in practice. So let's move on to the demo now. Okay, so as mentioned, we're going to use the Wi-Fi SoftAP based provision sample from the nRF Connect SDK. You can find the documentation if you go to samples, scroll down almost all the way down to Wi-Fi, and we still have a subcategory here, provisioning samples. So in previous SDK, we only had Wi-Fi Bluetooth LE based provision, and now we have an additional, so SoftAP based provision. So now these two samples fold into Wi-Fi provisioning samples category. We should also have an NFC based provisioning sample coming in a future SDK release. Okay, so I also have then so I've already flashed a built-in flash this sample to the nRF 7002 DK, which I have connected to my computer. Let's just look briefly at the LED interface. So LED 1 indicates that the device is advertising the SoftAP network. So this is the network that the mobile device will connect to be able to provision nRF 7002 to the actual Wi-Fi network. And when that happens, then we should see that LED 2 will be the one that turns on when the device is then connected to the provisioned Wi-Fi network. So I'll bring up the kit into frame here, and I also have then serial terminal application from nRF Connect for desktop to see the messages coming out of the firmware. So the first thing I'll do is actually press button 1, and this will clear the credentials in the firmware, if any. So make sure that we sort of start from a blank state, let's say. Okay, so now we can bring the mobile app. Okay, so here we go. Let's bring that. Okay, and we're going to open the nRF Wi-Fi provisioner there. So this is the same mobile app that's been out in the App Store for about a year, I think. Initially, it only supported provisioning over Bluetooth LE. Now we've also added support for provisioning over Wi-Fi and provisioning over NFC. We just don't have a sample yet to demonstrate that solution. So we'll go and select provision over Wi-Fi. The device SSID is the default one in the sample, so I'm not going to change that. So I'll just go and click or press start provisioning and then press join. It will take a few seconds. So first we connect to the device and we can see the messages coming out on the left-hand side from the firmware. Okay, there's some progress. Okay, there we go. So we have all these networks here. I'm going to connect to the Nordic guest network. So when I select a network, it gives me a place where I can add the password. So I'll just paste the password there. And then we'll just select provision at the bottom. Okay. Then we can see here that we are now connected to the network. Yeah, so it's it's that easy. So first you connect over SoftAP. and then you will get a list of networks that NR 7002 will scan and provide that to the mobile app. You select the one you want to connect to, provide the credentials, and then the device will shut down SoftAP, and it will then connect to the actual access point that you want to connect to for normal operation. And as indicated by LED 2, we're now connected to the actual network. Yep. Okay. So this was the demo, and let's continue with the remaining topics in the webinar today. Okay, moving on to DECT NR+. So we have now added DECT NR+ to nRF Connect SDK for the first time. Specifically, what we did was add the DECT NR+ Phi API as experimental. And there's also a sample showcasing how to use the Phi library to do a sort of simple broadcast and reception of NR+ messages between two devices. However, to get access to the DECT NR+ Phi modem firmware, you'll need to contact our sales. So I'll leave a link here on this slide that takes you directly to the sales contact form, or you can just go to nordicsemi.com. Then from the menu, select company and then you'll be able to see the contact option right there at the bottom of the menu under company. So that will take you to the same place as this contact our sales link in the slide. Yeah, so one of my colleagues has written a DevZone blog on how to get started with the NR Phi and test these samples. It's this one here at the bottom, getting started with NR+ Phi, sorry. So I recommend that you give that a read if you're interested, and I'll leave some additional resources on this slide if you want to learn more about the NR+ in general, from a high-level technology standpoint, applications, and so on. Both resources from Nordic as well as the DECT forum that has also some webinars, which I really recommend watching if you want to learn more. Yeah, and and the last topic of today's webinar will be Edge AI, and I'm going to hand it over to Robin to go through the slides and show us a demo also of Nordic's ML Studio.
So this is a screenshot of how a project looks like in Nordic ML Studio, which is our platform for performing ML training, powered by our friends over at Edge Impulse. So ML Studio is a low-code model for development, uses a low-code model for development, where you can import from popular frameworks such as TensorFlow, TensorFlow Lite, and such. And you can also develop models completely in the platform. And there's no black boxes for the things you develop, so it can be both. You can look under the hood to see what's going on inside, and you can also export and use on other platforms if you wish. You can also use this platform to profile the performance of your model for the target device that you wish to run it on. For example, the ARM M core that is in your nRF SoC. You can deploy in multiple ways. One way is to deploy as binaries, specifically for your Nordic device. You can also deploy as optimized C++ libraries, which can be optimized using this edge optimized neural compiler that Edge Impulse creates that optimized for reduced RAM and non-volatile memory usage. It also has some dataset management tools, like for collecting data to train on, and also for doing data science operations on your existing datasets. Then it has the deployment to edge devices, either as C++ libraries, as I mentioned, that you can download and use in your nRF Connect SDK applications, or you can also download precompiled binaries to flash to your Thingy53 or your dev kits to test out your model in a seamless way. This is the learning workflow that I have borrowed from Edge Impulse. And all of this in the bottom line is where you create your ML model. This happens in ML Studio in our case, where you collect data and handle your data sets. You develop your model and your algorithm, and then you build and validate your model and your performance. Do the Eon compiler to optimize it for your device, and then also you select how you wish to deploy it, if you wish to deploy as a binary or as a C++ library. Then you can use the Thingy53, for example, and the nRF Edge Impulse app to both collect data sample points from the Thingy53 sensors and upload them over Bluetooth to a phone with the app, and then use the phone's internet connection to get all of those data into your ML Studio project. And you can also use that same app to download this precompiled binary and do a DFU from the phone to the Thingy53 to test your model on the device. For the demo in this webinar, I will be doing it a little bit differently. I have the nRF 7002 expansion board, a Wi-Fi expansion board for the Thingy. So this lets me connect my Thingy53 directly to the cloud via my internet access point, of course, which means I skip this Bluetooth intermediary step to get the data samples up into the cloud. I still will have to use the nRF Edge Impulse app to deploy firmware to the Thingy if I wish to test it out. I'm not doing that in this demo, but the expansion board and the platform doesn't support DFU over Wi-Fi. There's some highlights for Nordic ML Studio. First of all, it is completely free to use. The features are all available, and we do not take any fee for this at the moment. The supported targets are easily selectable because it supports only Nordic dev kits and thingies, so you don't have a clutter of other devices to select from when you don't need them. You can have an unlimited amount of private projects, so you're not limited to a few, like with other free alternatives. You also have full access to both the Eon compiler, so the Edge optimized neural compiler, and the API support of the ML Studio. If you have any issues, Nordic will support you directly through DevZone. And if you need collaboration features, which is called organization features in this platform, we can enable them for you on request. The currently supported targets are the nRF52840 SoC with the nRF52840 DK, the 5340 DK, the 7002 DK, and the Thingy53 DK, which all uses the nRF5340 as their SoC. And then you have the 9160 system in package in the 9160 DK and the Thingy 91. And by extension, we're also working on support for the nRF 9161 DK with the nRF 9161 system in package. And for launch of the nRF 54H20, we're also working on support for the nRF 54H20 development kit. And then we will go to a demo. So when you log in to ML Studio, it looks like this. If it's your first time logging in, you need to create a new project, of course, with this button. I have already created a project here. And the first thing we want to do to train an ML model is to get some data into this project. That's why I have connected my Thingy53 with the Wi-Fi using the nRF 7002 expansion board. We can see it right here. And to gather some data, we will go to data acquisition and we will select the device and we will give it the label name. I will call it hello thingy because that's what I'm going to say. I don't need 10 seconds. It will do with probably 2. And then of course it's the microphone we're using here. Then I start sampling. It starts counting down with red flashes and it samples with blue flashes. Hello thingy. And then you can see here we have a waveform that represents the audio. Hello thingy. And we can play it back. And once we have selected, once we have sampled enough data, we can go through the impulse design process and select the time series data, parameters you need. You can add DSP processing blocks. There are many to choose from. You can also import your own. You have learning blocks. There are many to choose from, but you can also bring your own model from different architectures. And once you are happy with your model and you have trained it, you go through the Eon tuner to tune it for your specific target. For example, your Nordic SoC. let's look at existing project to see how this looks like. So you get different options with different strategies that have different levels of performance. So typically you would select the one with the best performance and retrain on that. Then you can go to a deployment, and you can either deploy as a C++ library, which is what we did for this one. I built the model into my nRF Connect SDK application. But just for testing the model, you can also select any Nordic dev kit and get a precompiled binary that flashes with the nRF programmer app in nRF Connect for desktop. Or you can select the Thingy53 and flash it through the nRF Edge Impulse app on mobile.
Okay, thanks, Robin, for that great, great topic of JI going through the Nordic ML Studio, and a great demo as well. So we have now reached the end of our webinar. For easy steps to get going, you can sign up for more webinars at webinars.nordicsemi.com. Of course, if you want to get hands-on and more technical, you can always take our interactive courses at academy.nordicsemi.com. For tech support or any kind of troubleshooting assistance or general, anything you basically need from Nordic when it comes to technical topics, go to devs.nordicsemi.com. And if you want general information about our products and services, head out to our corporate website, nordicsemi.com. And let's now move on to the Q&A, and let's try to get as many questions answered as possible that came during the webinar today. Yeah, so we only had 2 questions coming in. The first one, I'm not exactly sure if I understand. Is there I think this is only Bumble HCI bridge, which we need to be connected. This is probably related to the Bluetooth feature that we talked about. So essentially what this means is that from your application, if you want to get access to the link loss feature, you need to call HCI commands directly to the soft device. So there's no host stack API available that will give you access to this feature. And then the other one is when will the 2.7 SDK be on the full release of nRF Connect for VS Code, and where should I look to get notified when it does? So, 2 questions here. The first one, I don't really have an answer for this. We're trying to do it as quickly as possible, but we don't have there's no timeline we can communicate at this stage. When it comes to notifications, I mean, if you're using VS Code, then you will see today, you will see a warning there on the top left due to the lack of support for or experimental level for nRF Connect SDK 2.0, so the hardware model v2 and assist build. And typically, the default behavior in VS Code is that the extensions will automatically update. So you might not notice that you have a new version. So whenever it's released, it will automatically update in your VS Code installation. So, and that warning should then go away. So that will be an easy way, sort of a visual cue that will tell you that you have a new version. And then the other way would be if you can also subscribe to our product update notifications, and we'll send out an email when the new version is out with support for nRF Connect SDK 2.7.0. Okay, 2 more questions came in, so I'll go and check those out. Will there be a new Dev Academy class for SysBuild and a new hardware model? Not the new class or new course, but yes, this is something that will definitely add to existing courses. I'm not exactly sure if it's going to be in the nRF Connect SDK fundamentals or in the intermediate, but this is something that will definitely add to the courses in the coming months. I also don't have a timeline on that. And one more question: is there a template for Matter water leak sensor device type? So there was a lot of stuff coming in Matter 1.3, as you saw, when it comes to new device types. We don't have samples for all of these, but we do have a generic Matter template sample, and that can be used essentially to develop any kind of Matter device. So that would be your starting point. And then we have documentation that tells you how you add specific devices on top of that template sample. So that would be the place to start. And one more question. Yeah, we'll keep them coming so I can still address those as during the webinar. Will the nRF 9151 be supported by ML Studio? Yes, it will be supported. The reason why it wasn't mentioned in during that section is because it's not a launch product. We have announced it, but we haven't launched it yet, so it wasn't there. But the expectation is that it will also be supported by the ML Studio that Robin presented today. Okay, so it seems that we don't have any more questions. So I'd like to thank everyone for attending today. We have another session in the afternoon. And of course, if you have more questions, head out to DevZone and our tech support team will be able to support you guys on those. Okay, thank you and have a nice day. And we'll hope to see you again on a future webinar. Thanks. The first question is about VS Code extension, nRF Connect for VS Code, asking when can we expect to have that compatible with the hardware model V2. So yeah, it's always tough to comment on timelines. What I can say is that we're doing everything we can to get this supported as quickly as possible, including having nRF Connect SDK 2.7.0 as supported in the release version of the extension. If you want to stay on top of this, of course, the extension will update itself by default. I think that's the default behavior in VS Code when there's a new version. One way to see when this happens is that if you have the latest version of the extension today, the release version, not necessarily the pre-release version. If you look on the top left, you'll see that there's sort of a warning icon. That it is the warning that's related with the message that you'll see saying that the nRF Connect SDK 2.7.0 is experimental. So when you see that the warning has gone away, most likely you have a new version installed, automatically. And then you can go to the release notes and see if that is the version that supports the SDK. So yeah, can't really comment on timeline. The other way to stay on top of this is if you subscribe to our product update notification newsletters. If you have done that, you have probably received one when we released the new version of the SDK, and when we have the VS Code with support for 2.70, we'll send out a product update notification email as well to notify all customers that this is now supported and they can go in and use it in sort of for a production environment. Okay, another question. Can I program Thingy with VS Code without a programmer? Well, yes and no. Yes, because you can use nRF util on the command line, which is built into VS Code. But I guess here you're referring to the actions menu where you have the build in Flash. So there we don't have support for that yet. Our intention is to have support there because those actions they're actually using nRF util on the backend. So it's really just a few tweaks that need to be done, on the back end of that to support the thingies. But sort of related to the previous question, the focus really now is on supporting nRF Connect 2.70, and then it's sort of going back to additional features. And we'll look back at things like this using the thingies directly from the VS Code shortcuts. And then one related with the Find My, so FMD. If you sort of need Google's blessing, like we need to paperwork. Yes, so you need to register your ID, let's say, with Google. So if you go to the link in the slides, I share the link to the slides where you can download them. So you'll go to the FMD slide. There's a link to the specification, and on the very top of the specification page, that's a page from Google, you'll find a link to the registration form. And on that registration form, that's where you sort of write down your idea. I'm not, to be honest, I haven't seen that form, so I don't know exactly what you need to add. But yeah, there is a process here to get things approved, registered, and approved by Google before you can go to market with a device that has FMD functionality. For development, you shouldn't need this. We have keys that can be used, but for production, you need to get things from Google to get to go out to market. Where are specific instructions to migrate to sysbuild? I also share the migration guide links on the chat. Not for each of these individually, but for the sort of the section that has all the migration guides for the 2.7. You'll find those right at the very top of that table of contents. Is there plans to support Edge AI on the nRF 52L15? Yeah, so that wasn't on the slide with the hardware support. I would need to get back on that one. I mean, there's no reason why you can't run machine learning algorithms on the nRF 54L15. I mean, that's a device more capable than some of those that you saw on that slide, like the 91 series, for example, the 9160 and 9161, and also the 9151 that hasn't launched yet, but that we announced back in February. So that might have been just a hiccup on the slide. But I will have to get that confirmed before giving a clear answer that this will be supported. But I guess the answer at the moment is that there's no reason why it shouldn't be. But we'll have to get back on that one. And I think that was the last question, if there are no more questions. So I'd like to thank everyone who joined, and yeah, hope to see you again on a future Nordic webinar, and have a good day, morning, evening, wherever you might be located, and hope to see you again. All right, thank you.